Exposure for photographers. What is exposure? An exposure occurs whenever light strikes a sensitized surface such as photographic film or a digital sensor. Digital camera sensors are comprised of millions of microscopic components called pixels. Pixels act like tiny buckets that capture particles of light called photons. Pixels that collect a lot of photons become the brighter parts of the picture. Pixels that collect less photons become the darker parts of the picture. How do we control exposure? The photographer's goal is to make a picture that is not too bright, which we call overexposed, or too dark, we call that underexposed. We also need to make sure that the color in the photo is accurate. We use certain camera features to adjust and evaluate each exposure and color condition. It's important that you know what these features are, where they are located on your camera, and how they affect the appearance of your picture. Once set properly, the camera can do much of this process automatically. For this tutorial, use your camera's instruction manual to help locate and operate your camera's specific features. These are the camera features you need to be familiar with. White balance, and you'll find more about white balance on page 99 of your instruction manual. White balance controls the overall color quality of your photograph. Now, what we mean by this is that different types of light sources produce different colors of light. Now, our eyes and our brains can interpret these differences accurately without really thinking about it. But cameras can't, so we have to tell the camera what type of light source we are using. For instance, sunlight, artificial light, etc. For instance, an incandescent light, which we think of as regular light bulbs that you would have in a lamp in a room, incandescent light looks yellow, as in this picture. So on my camera, I'm going to select the incandescent white balance setting, and the camera gives me accurate color. Now, the incandescent white balance setting looks like a little light bulb, and your instructor will show you how to set that. Cloudy or shady light outdoors actually looks blue. So we select the cloudy or shade white balance setting on the camera to get accurate color. Bright sunlight and flash results in very accurate colors, as long as daylight or flash white balance is selected on the camera. Now, if the white balance is set for cloudy, but I'm still under bright sunlight, the picture winds up looking too yellow. And if the white balance is set to incandescent under bright sunlight, the picture looks too blue. And for complicated or creative lighting situations like this picture taken at night, we try different white balance settings to achieve interesting effects. So white balance is a creative control as well as a control for accurate color. Now, the simplest way to set white balance is to use auto white balance, or AWB. Auto white balance will give very accurate colors under most lighting conditions most of the time. But when it doesn't, the photographer can choose one of the other settings to more closely match the color of the light source. Your instructor will show you how to change the white balance settings on your camera. Now, the next topic is called metering mode, and that's on page 86 of your instruction manual. Your camera has a built-in light meter that is designed to give accurate exposures. The goal is to make pictures that are not too bright or too dark. The light meter can evaluate light in various ways. The simplest and most accurate metering mode is to use evaluative. Your instructor will help you find evaluative metering mode on your camera. Now, we like to think of exposure as equaling balance. Each time we make an exposure, the photographer must try to bring into balance three variables. They are how much light enters the camera, how long should that light strike the sensor, and how sensitive to light is the sensor. So let's start with how much. And we control how much light enters the camera by adjusting the lens aperture. As the aperture opening gets bigger, more light enters the camera. As it gets smaller, less light enters. The numbers associated with the size of these openings are called f-stops. f-stops with smaller numbers like 3.5 or 5.6 on the lenses that you all are using mean the hole is bigger, which allows more light to enter. F-stops with larger numbers like f11 or f16 mean the hole is smaller, which allows less light to enter. This is what the aperture in your lens looks like. And you can see it's multiple blades, metal blades inside the lens between the pieces of glass. And by turning a ring on the lens or a ring on or a dial on your camera, you can make that opening larger or smaller. Now, you may not be able to see it open and close on your camera. Modern cameras, digital cameras, don't allow you to see this open and close. It only opens and closes at the moment of exposure. It's very much like the blinking of an eye. You will see a display in the viewfinder that tells you what aperture the camera is using. And at the end of this tutorial, we have a slide that shows you where to find this information inside your viewfinder. You can change the aperture by rotating the control wheel on the front of your camera with your index finger. So while we're talking about apertures, let's talk about depth of field. The size of the aperture controls this thing we call depth of field. Large aperture openings, small numbers, create very little sharp focus front to back. We call that shallow depth of field. Small aperture openings, large numbers, create lots of sharp focus front to back, greater depth of field. So let's look at some examples. The first example was shot at f2.8, which is a very wide or large lens aperture. And the second was shot at f22, which is a very small lens aperture. Now here's the first image. You see that this collection of small figures has very, very shallow depth of field. So the figure in the very front of the picture is actually out of focus. The figures that are in a bit, that are a little bit deeper into the shot, are in sharp focus, and then the figures behind them are out of focus as well. So what this picture demonstrates is how shallow depth of field can create a sense or the illusion of depth. I'm going to show you another picture. The camera didn't move. The only thing that changed was the size of the lens aperture. Now in this picture, everything is in focus, and that's because we made the lens aperture smaller. The smaller opening, which has a larger number, creates sharper focus from the front of the picture to the back. We didn't change the fact that the lens was focused on the two figures about a third of the way into the picture. The only thing that changed is the size of the aperture, which increased the range of sharp focus. So exposure equals balance. You'll notice that in the previous examples, as the aperture changed, only the depth of field changed. But we know that as the aperture gets bigger and smaller, we let more or less light into the camera. So in order to keep the picture from getting brighter and darker, the camera's light meter balances the exposure by changing how long the sensor is exposed to light. This is important. The balance between how much and how long is very important. So when we talk about how long, what we talk about is shutter speed. Inside the camera, just in front of the sensor, is a pair of delicate curtains called the shutter. Like a watch or a clock, the shutter controls the length of time the sensor is exposed to light coming through the lens aperture. We call that length of time the shutter speed. Shutter speeds are designated in fractions of a second. Slower shutter speeds, or longer exposures, have smaller numbers like 1/2, 1/8, 1/30, etc. Faster shutter speeds, or shorter exposures, have higher numbers like 1/125th of a second, 1/500th, 1/2000th, etc. To maintain balance, small lens apertures, which have bigger numbers and allow less light to come into the camera, require longer shutter speeds, while larger lens apertures, which have smaller numbers and let more light come into the camera, require faster shutter speeds. Now that's confusing, isn't it? You need to be careful because longer or slower shutter speeds result in blur because it is unlikely that you can hold the camera still. This is where tripods or other camera supports become necessary. Now, shutter speed also controls how moving objects appear in your pictures. If you use a fast shutter speed, maybe 1/125th of a second and faster, movement is frozen sharply. If you use a slow shutter speed, 1/30th of a second and slower, movement appears to be blurred. Remember, it is difficult to hold the camera still if the shutter speed falls below 1/60th of a second. The result will be shaky, blurry pictures. A tripod is necessary for those shots. These examples may help you understand the balance between aperture and shutter speed, or the balance between how much and how long. In the following pictures, the aperture was changed to demonstrate depth of field first. The first shot of the blue train was shot at f2.8, a large lens opening which, remember, lets in a lot of light, but it results in very shallow focus. The shutter speed then had to be fast, 1/160th of a second, in order to balance out the light coming through the lens aperture. The second shot of the blue train was shot at f22, a small lens opening which resulted in less light coming into the camera, but it also resulted in greater sharpness front to back. But the shutter speed had to be very slow, 1/2 of a second, since there was very little light coming through the lens aperture. So there's the first shot. Very shallow depth of field. You'll see that first yellow sign on the car right behind the engine is really the only sharp part of this picture. Shallow depth of field, a wide lens aperture, f2.8, and this is what the picture looks like. Now, just like the previous examples, simply by changing the lens aperture, we increase the depth of field, but obviously when we change the lens aperture, we let less light through the lens, so the shutter speed has to balance accordingly. The shutter speed has to get longer to keep the same brightness to the picture. Now, there's nothing moving in these two pictures, so the fact that the shutter speed gets longer or gets faster or slower doesn't really have a visual effect on the picture. In order to see the visual effect, we have to add some movement. So if you look at the first shot again, the one with the shallow depth of field and the fast shutter speed, this time we'll add a moving black train coming toward the lens. In the first picture, it appears to be frozen in place due to the brief exposure. Remember, it's 1/160th of a second. Adding movement to the second shot, the one with great depth of field but with a slow shutter speed, results in a blurred train. It was roughly 1/2 of a second for that shot. So here's the first shot. The black train appears to be still, even though it was actually moving quite rapidly toward the lens. And you can see the same depth of field effect that we had in the shot of the blue train by itself. Shallow depth of field, wide lens opening, lots of light comes into the lens, results in a faster shutter speed to keep the balance. The faster shutter speed will freeze the motion of the train that's moving. In the second shot, we make the lens aperture smaller, a smaller opening, a larger number, less light, equals more depth of field. But it also forces the shutter speed down to a much slower speed so that the time that the sensor is exposed to light actually balances the lack of light coming into the lens. As that train, the same black train, moves toward the camera, you see that it just records as a blur. So that's the difference between 1/160th of a second and 1/2 of a second, and these two pictures also demonstrate the relationship between depth of field, which is controlled by the aperture, and the rendition of movement, which is controlled by the shutter speed. Now, if you understand all that, congratulations, you're a photographer. Photographers control that balance between aperture, which is how much light, and shutter speed, which controls how long the light strikes the sensor. They do that just to control the brightness of the picture. But there's a difference between the brightness in the picture and making an interesting, effective photograph. So photographers obviously have to think about making the picture correct when it comes to brightness. But they also have to think about how to use depth of field and how movement or motion is rendered in the picture in order to make the picture interesting and effective. Now, to simplify all of this, we suggest that you set your camera's exposure mode to P, which stands for program. This will lock all of the aperture and shutter speed combinations together so that you can choose from those combinations the right effect. But you must know what those numbers mean when the camera tells you what shutter speed and what lens aperture it's using. This chart may help you understand this concept a little bit better, but this will take some practice. So in this chart, we see a series of numbers in the middle of the frame. The top numbers, 1,000, 500, 250, 125, 60, etc., those are all shutter speeds. And remember, shutter speeds are fractions. So 1,000 is actually 1/1000th of a second. Now the numbers below the shutter speeds are lens apertures, 1.4, 2, 2.8, 4, 5.6, etc. Your lens may not have all of the smaller numbers like 1.4, 2.8. I believe your lenses all start at 3.5. So the fact that the numbers on this scale don't correspond with your lens, it's not really a big problem, but just realize that not all lenses have exactly the same lens apertures available. It depends on the design of the lens. So shutter speeds on top, lens apertures on the bottom. And the assumption looking at these numbers is that there is a certain amount of light available to us to make a picture. And with that certain amount of light, we have combinations of shutter speed and lens apertures that we can choose. Every one of these combinations of shutter speed and lens aperture will give us the same brightness in the photograph. The exposure will be the same. But it's up to us as photographers to look at these numbers, the combination of shutter speed and lens aperture, and decide which combination is actually appropriate for the type of picture we want to take. So if we were to take a picture of something at 1/1000th of a second at a lens aperture of 1.4, that's the combination that appears on the left, what will happen is the fast shutter speed will freeze any motion happening in the picture, while the very wide lens aperture will create very shallow depth of field. So fast shutter speed, you can freeze motion. Wide aperture, you create shallow depth of field. At the other end of the scale, 1 full second will equal that's a very slow shutter speed and will result in anything moving recording as a blur. But the lens aperture, f64, which most lenses don't even include in their design, but f64 will give you very, very great depth of field. Everything in the picture from front to back will most likely be in focus. So those are the two extremes. And this is why you have to look at the numbers, the shutter speed, and the lens aperture that the camera is displaying when you're taking a photograph, and have those numbers actually make sense to you as far as what effect they have on the appearance of your picture. Okay? So top numbers, shutter speed, bottom numbers, lens aperture, and then above the shutter speed, you'll see if we go in one direction toward the left, we're actually moving faster, which will stop motion. If we move in the other direction, we're actually going slower, which will blur motion. Underneath the numbers, we have the relative size of the lens openings. The big circles equal less depth of field. The smaller numbers, big circle, big aperture, less depth of field. And as we move to the right, the size of the lens aperture gets smaller, but the depth of field increases. That is the relationship between shutter speed and aperture. All of these combinations give us the same brightness, but they do give us different pictures. The pictures look different at each of these combinations. Now the last part of this is ISO. And ISO is a number that's used to designate how sensitive the camera's sensor is to light. As the number gets higher, less light is needed to make a picture. As it gets lower, more light is needed. High ISO allows the use of small lens apertures in dim light, giving the photographer greater depth of field. High ISO allows the use of faster shutter speeds in dim light so that movement can be frozen. But low ISO maintains maximum image quality. So when we talk about ISO and image quality, we need to understand that as you increase the ISO on your camera, you increase the flow of electricity to the camera sensor. This results in greater sensitivity, but it also results in something called noise, which is not very attractive. Photographers always use the lowest appropriate ISO for any particular situation. Your goal should be to start with the lowest ISO on your camera and only raise it in dim light. And I really recommend that you test your camera's ISO settings to see when the image quality becomes unsatisfactory by looking at it very closely like this. Now in the first picture, this is the full photograph shot at ISO 200, which on my camera is the lowest possible ISO I can use, which results in the highest possible image quality. So what I did for the following pictures is I cropped a small portion of the picture and then changed the ISO each time I shot the picture to make the ISO go higher and higher and higher. As the ISO goes higher, obviously I had to change something about the other components of the exposure, the shutter speed or the aperture. In this case, I changed the shutter speed to keep the exposure in balance as I made the sensor more sensitive. All right, so here's the uncropped picture at ISO 200. And just as a reference, here's the crop at ISO 200. You see there's a lot of detail. It's very smooth. The color looks very accurate. This is a high quality digital image. Now for the next picture, I shot the same photograph and cropped it exactly the same way, but this time I shot it at ISO 800. And at ISO 800, if you look carefully, you will start to see kind of a grainy, granular kind of quality to the picture start to appear. It's perfectly satisfactory. It's not obvious, but you can see the difference between these two pictures. I shot the next picture at ISO 1600, and now the grain becomes more, or the noise, excuse me, becomes more obvious. Once again, at ISO 3200, now the noise becomes almost unacceptable, and certainly by ISO 6400, I have kind of a big mess on my hands. Now, as cameras become more and more capable of high quality, high ISO pictures, this is harder and harder to demonstrate. But with the cameras that you're using, and obviously the camera that I use, you will see high ISO become very apparent in your photographs. Probably in your cameras it will become apparent way before ISO 6400. And in very new cameras and very expensive cameras, even ISO 6400 is quite good. Now, one last slide here. This is the what you see when you look through your camera's viewfinder. Now, there's an awful lot of information here that you probably don't need to pay attention to, but we did highlight the important information, where you find your white balance setting, where you can find the ISO speed, where you can find the lens aperture, and where you find the shutter speed. So all of that information is available to you in the viewfinder. You need to practice looking for this information and understanding what those different numbers and what those different symbols mean to the quality of your picture. So with that, I want to say thanks, and we hope that this helps you begin to understand exposure a little bit better. For more information, please refer to your camera's instruction manual, and I hope you have a lot of fun making great pictures. Thanks again.